Hello. Okay, today we are continuing from the last video or the last class about this. But we have did in last class about the concept of the introduction of introduction of electricity, that is about charge, the concept of charge and then the definition, and then plus we did the potential, then the electric current, and then the properties of charge. Okay, and today we'll continue from that, and some part we are missing from there, that direction of flow of current. What types of current we'll do? Only conventional current, we won't do the electronics current. Okay. Now, from what we have studied, that electric potential, I forgot to tell you, that electric potential is the one that will tell where is the direction of current flows. Means from where the current flows, from which part, from this side to the side or from this side to this side. Mean, example, this is conductor. Current will flow from where, from this side to the side, or whether from here to here. Okay, that who will tell that it is electric potential. Mean direction is given by. It is given by potential, capital by electric potential. By electric potential. Okay, let me draw a conductor here. Consider this is a conductor. Okay, now in this conductor, where is the direction of electric current? Okay, let me consider this conductor is supply some potential here. Okay, it supplies some potential. Now consider here there is a battery. Okay, consider this is a battery. Now this conductor is connected with this battery. Then when you look in this battery or cell, mostly we call this cell only. But in generally you thought this is a battery. But I'll tell you what's the difference between cell and battery. Okay, most of the time you see here is positive and here is negative. And where's the direction of current? Maybe somewhat you already know the direction of current is from positive to negative, because direction of current will flow from this positive. This is called positive terminal. This is called positive terminal. Then this will be negative terminal. Okay, now the current will flow from positive to negative. That's the direction of current. And what I tell you, direction of flow current is given by electric potential. What's mean this? Mean positive terminal means higher potential. Positive terminal means higher potential, and negative terminal means lower potential. What's mean this lower potential or higher potential? In higher potential means at this point they have higher energy, and at this point they have lower energy. For example, let me draw here. Consider here that this is some ground, and here also there is a ground. An example here there is a one top, and here also one more top, and here it is full of water. In this top, and this top is being connected to this top with a pipe. This top is being connected. Now where this water, okay, let me put here first. I'll do this. This one is at the higher level, then this one is at the lower level. Then the water where it will flow. Water, obviously you already know that water will flow this direction. I mean this is the nature of what? Nature of the environment. You cannot change that. You cannot say that water will goes up. Okay. Then water will always flow from higher level to lower level. Okay, then if example here is there is no water, but here there is water. Will this water will move up? The water doesn't move there. Then in that case, if you want to move this water from here to here, you have to apply some external source, some external energy. If you want this water to move up, you have to apply some source. That would be electric motor. We used to give electric motor to pump this water up. But here, I will talk from here, from higher level to lower level without electric motor. Then water will always flows from this side to this side. Then similarly for current will always flow from higher. Like here is higher potential, this is lower potential. Water will always flow from higher to lower. Then same for current is always from higher to lower. Then remember, when to make that this current will move, otherwise there will be no flows of current. To maintain that this current will continue to flow, remember the difference between, okay, let me take here, the potential here is V1 and here the potential is V2. Remember there is always, remember V1 should be always greater than V2. Remember that potential at this point should always greater than potential at V2, then only the current will flow. Otherwise, if this V1 is equal to V2, now if V1 is equal to V2 means if potential at this point is equal to potential at this point, then there is no flow of current. Then in that case you said, okay, then the battery is low. Then there will be no more current. Then remember, to maintain that the current will flow continuously, to maintain that the current will keep on flowing, we have to make the difference between the potential should always different. But we want to get a steady current. Steady current means the current does not change, does not low, does not high. In that case, we have to make the difference between these two, potential V1 and V2 should always the same. Okay, let me write this. V1 minus V2 mean the difference between V1 minus V2 should always give the same value at every time. Then only we can get a steady current. Steady current means same amount of current. Then how we know that electric current flows from where direction, from which direction to which direction? Only from higher potential to lower potential. Then if I change this, now if I put here it's a negative, then here will be positive. Now this will become the higher potential, then this will become the lower potential, and the current again will move from this direction. Now this type of current will be called as conventional current. But if you talk about electronics current, because mainly in your syllabus we do only conventional. But if it talks about electronics current, then the current will flow from negative to positive. That's the difference. Okay, now and note this one. This will be important. Remember, R is always has a zero potential. R is always has a zero potential. Okay, example here that we have taken here is negative, then here is positive. If this negative is zero potential, then this positive is a higher potential, then the energy will always flows from higher to lower. Then example here, R is always a zero potential, is at zero potential. Then whenever you build a house, a new building or new house, you always connect that earthing. This earthing is always connected to the ground. Why? Because whenever the current flows to the ground, the earth is always at zero potential. The energy, it never increases. How much time is supplied, also then this point it never equal to this higher potential. Then always lower, then always the energy is supplied to the ground. That is used for safety for earthing. Okay, we'll come to that in the next part. Okay, then earth is always has a zero potential. Then okay, what else from here? Okay, now we look about this positive, negative and zero potential. Don't confuse this. Remember, positive means higher potential, means higher, they have more energy. Then negative means lower potential, means they have less energy. And zero potential means zero energy. And look, remember, whenever you see this type of line, this shows that the potential or the wire is connected to the ground. This is ground. Whenever you see this type of diagram, this is shown that this wire is connected to the ground. Then similarly, this wire is connected to the ground. So this is a positive conductor, then this will be at a higher potential. Then this is a negative conductor, this will be at a lower potential. Then this, how much potential here is? Zero potential. Zero potential. Potential SI unit will be volt. In last video we have write that SI unit of volt, symbol will be V. Then here the voltage here will be negative volt. Then here will be, again, this is ground. Then here again this will be zero potential. Then here will be positive potential. Now negative and zero, which is higher? Which is greater, 0 or minus? Which is greater, 0 or minus? It is 0 is greater. Then if 0 is greater, then where is the direction of current flows? From this conductor to the ground, or from the ground to the conductor? The current or the potential or the energy will flow from 0 to negative. This is the direction. And this will be the conventional current. Now from 0 to negative, because since why? Because 0 is greater than minus. But here positive is greater than 0, then here it will be to the ground. Now the direction here from positive to 0. Then remember, all is always at 0 potential. And remember, which determines the direction of flow of current? Which determines the direction of flow of current is electric potential. Which determines the direction of current? Electric potential. Okay. Now this, at least remember this, mean the current always flow from higher to lower. Then it won't flow from lower to higher like water. Okay, then we'll come to next part, that will be the continuous current. Okay, now come to this. How to obtain a continuous flow of current. What's the meaning of continuous flow of current? Continuous flow of current means the current will flow continue. It doesn't stop and it doesn't high, it doesn't low. It remains the same. That's the meaning of continuous flow of current. Everyone wants that the current will flow continuously. Otherwise, sometimes you have dim bulb, sometimes you have the light is so high and the light is so dim. The intensity of light are very small and sometimes very large. Then we don't want that. We want the continuous flow of current. Then how to obtain this? Then to maintain that the continuous flow of current, remember, you already know that the current, the potential always flow from higher to lower. Then consider this is a conductor. I'll explain to a conductor. Consider this conductor. This one end of conductor. Okay, consider this is a one end. One end of this conductor. This is under end of conductor. In the second end. Now let's say this first end. This will be at higher potential. Then this will be at lower potential. And the current always flows from higher to lower. Then to maintain that the current flows here on this wire. Okay, the current flows on this wire or on this conductor should remain continuous. Means it should be constant. Everywhere it should be the same. Then remember, let's say this is higher potential, highest potential, and this is a lower potential. Remember, the higher potential minus lower potential at every time means it should give constant. It should give constant. Means the difference in potential. What's the meaning of this constant? The difference in potential The difference in potential should always, what we constant, the difference in potential is the same, it's always the same. The difference in potential is always the same. Look, the potential at higher minus lower, it should always give constant at every time. Means let's say at 2 seconds, the first 2 seconds the potential is 10 ohm, example the difference between. Then after the next 2 seconds, the difference between two potential is always remain 10 volt. Okay, I'm killing that mosquito, then don't laugh. Okay, now how to obtain continuous flow of current? Continuous means what's mean of continuous in another form. Continuous flow of current, this will be called as steady current. What's the other name of continuous flow of current? It is a steady current. How to obtain a steady, if they ask you another form, how to obtain a steady current? It means how to obtain a continuous flow of current will be same. That to obtain continuous flow of current, it should be maintained that the highest potential and the lowest potential, their difference is should always constant. The difference in potential is always the same, so that the current should be steady. Otherwise, if the difference, this minus, if the difference are changing, are varied, then the current also it won't be steady current. It will change to varied current or instantaneous current. Okay, now this will be, and then, and how, and who will make, and who makes that current should be steady, and from where we have to do, we have to get some source to supply energy so that the potential will always remain the same. Then to get this higher potential should always remain the same, and lowest potential also should always remain the same. When we minus also will get the same value at every time. Then who will maintain that? We have to supply external energy. Okay, we need some source of energy. To maintain this, higher potential should remain the same, lower potential also should remain the same. When we subtract them also we should always get the same value. Then that will be, we have to apply some source of energy. And who's that source of energy? That will be, we can get as from mechanical energy, chemical energy, then what else? Mechanical energy, chemical energy, then thermal energy. All from this. And what is this chemical energy? This will be, example, dry cell. Dry cell, you can ask me what is this dry cell? Dry cell means that you commonly call a battery. When you go to the shop and you ask, come a battery. Okay, that battery, what you call it, that is a dry cell. It doesn't mean a battery. I will tell you what's the difference between battery and cell when we come to that topic. Okay, then remember that battery what you buy in a shop is called cell, not a battery. Then mechanical energy, this would be mostly we get from turbine. That mostly is in hydroelectric station. Hydroelectric power, okay, hydroelectric power. Example, Umyang, you get from there. That will be used by turbine. And what about thermal energy? Thermal energy, this will be by the use of heat engine. That is with the help of petrol, diesel. Okay, from where we got the source of energy? From mechanical energy, chemical energy, or thermal energy. And mostly we get in Meghalaya, we get by mechanical energy. That is by using hydroelectric power to get a continuous flow of current. Okay, now we come to problem. Okay, but this how to obtain continuous flow of current or how to obtain a steady current. You try to write your own answer. I already explained. To obtain a steady current or continuous flow of current, we have to maintain that the highest potential or the lowest potential should always remain the same at every time, and the difference also should always the same, so that we'll get a constant difference, and that constant will give a constant flow of current. And please write this answer, okay, and send it to me in my WhatsApp number. Okay, now we finish this first part of this chapter, and then we'll do the problem, the exercise. Okay, first we'll do the simple problem, that will be practice problem 1 from the textbook, that will be page 109. And before we do this, let me recap that what we have did about electric potential. Electric potential means the work done or the energy spent on moving a charge from where? Moving a charge from infinity to a point inside the electric field. That we have talked in the last video. This will be okay. A charge, moving this charge from infinity, this point will be called as infinity. In bringing this charge from infinity to a point inside this electric field. This will be the electric field. Okay, that will be the electric potential. And potential difference means if one point here, then if another point here, then the amount of energy in bringing a charge from one point to another point, from here to here, then this difference, because this will be different potential, then this will be another different potential. Okay, then that will be this problem is related to this topic. Okay, now before we start this problem, let's recap the formula. Okay, and formula here will be very simple. Maybe I already given it in the last video. Then electric potential, okay, electric potential V, this is given as W by Q, mean work by charge or energy spent by charge. Okay, then potential different, okay, then this will be also will be like W, okay, like this, VA minus VB or V1 or minus, okay, I write V1 minus V2 in general. V1 minus V2, because the difference between 2 points. Okay, let's say this will be 1 point, this will be 1 point. Let's say this is point A, point B, or point B or point A. We don't know, let's see the problem. Okay, this will be the formula. We'll use in this problem, very, very simple. Okay, look this question. What is the electric potential? Okay, the ask for electric potential means this one. Electric potential V. What is electric potential at a point? At a point. So this is an electric field. Then let's say here is a point. Here is the charge. Then at this point, what is the electric potential? Okay, let's say this point as point A. Okay. Then what is electric potential at a point? We need to find electric potential at this point. At point A, in an electric field, inside this electric field. When 24 joule means work, means the energy you spend. 24 joule of work is done in moving a charge from where? Moving a charge from infinity. From here. Let's say the charge is from here, you bring it to this point. Mean how much is the charge? 84 coulomb. Mean this 84 coulomb from infinity, we have to take it and place it inside in the point A. Then how much is that point? Then what is the electric potential at that point? Okay, this will be question. What is the electric potential at a point? What is the electric potential at this point? When? In electric field. When 24 joule, in this is the energy you spend or the work you given. 24 joule of work is done in moving a charge of 84 coulomb from infinity. Okay, first to solve the equation. Okay, solution number 1. Okay, to solve, remember, in physics it's very, very simple, and also sometimes it will be very difficult. And remember, physics, if you understand it properly, is very simple. But if you don't know, it will be which formula I have to use, what I have to do, what I have to take, which step I have to do first, and what I have to do next. Remember, it is always write what is given in the equation. Once you understand what is given, then check what is asking to find, then recap the formula, which formula is related with that given data. Okay, now here, what is electric potential? Okay, you already understand what it asks to find, electric potential. Then I'll write this. Electric potential V, then this is question mark, we need to find. And then at a point in electric field when 24 joule of work, 24 joule of work, that will be the W. W is given this, work. Then work. Okay, alright, W is equal to 24 joule. Because SI unit of work is joule, or SI unit of energy will be joule. Is done in moving a charge, and charge also they give charge of 84 coulomb. Then given charge Q is equal to 84 coulomb, and we need to find electric potential. Then this will be a direct formula. Electric potential is equal to work by charge. Then you write here, we know electric potential. Electric potential V is equal to work W by charge Q. The electric potential V. The electric potential. What's one of work here is 24 joule. And then charge here is 84 coulomb. Then we'll do some cancellation here and then divide. Then can we do like this? Okay. 12 into 2 will be 24, and 12 into 7 will be 84. Then 2 by 7. Okay. Then what is the SI unit of electric potential? The SI unit of electric potential is volt. Then in your textbook they don't give answer 2 by 7. They give in a decimal point. Then you do your division. 2 divided by 7. Okay, everyone knows how to do division, then you can do it. Then 7 into 2 will be 14. Then next, here will be next 6, then 1, then 0 again. Then 7 into 8, 56. You keep on continuing. Then you will get this 0.28 volt. Now this will be the electric potential at this point. Okay, now this will be the answer, and very, very simple. Okay, now come to next question. Okay, we finish this question number 1, PP1. Then we do question number PP2, question number 1. Okay, that question number 2 from this PP1 you try by yourself. Then now we'll do PP2, question number 1. Then again question number 2 you do by yourself. From here also question number 2, HW. From here also question number 2, HW. Because both that HW are same as this one, then this will be same as this. Okay, now let's look at this question. Work of 25 joule. Okay, work of 25 joule and 30 joule is done when 5 coulomb charge is moved from infinity to point A and then to point B respectively calculated. Okay. And let's draw again electric field here. Let me put here there's a point A. Then we put here there's a point B. Let me check. Yeah, point A, point B. Now also this will be the electric field. Because I said move from infinity to point A and point B. Mean this point A and point B is inside this electric field. Now there is a charge here of 5 coulomb. Now this charge is from infinity. Then this charge is bringing from this point to point A, how much work? How much work bring? 25 joule. Then from this point to point A, from infinity to point A takes 25 joule. And then they said and work of 25 joule and 30 joule is done. Okay, then from this infinity to point B, it takes 30 joule. From infinity to point A takes 25 joule, and from infinity to point B is take 30 joule. From here is 25 joule. Then what is the electric potential between these two? Now, what is the potential difference between point A and point B? Then it's very, very easy. We'll do like this. We'll find first electric potential from infinity to point A, and then electric potential from infinity to point B. Then after that, we'll look what is the difference. Then we got electric potential difference. Okay, we'll always start with what is given. Given work. Well, 25 joule means from infinity to point A. 25 joule means the work from infinity to a point A. Then I'll write this WA. Means from infinity to point A. That will be how much? 25 joule. And then, 30 joule is done when move from infinity to a point B. Okay, then I'll take that one as WB. 30 joule. Work at point B. Then what is the charge they carry? 5 coulomb of charge. Let's write that Q is equal to 5 coulomb. Mean the given charge to carry from infinity to the point A and B is 5 coulomb. Then calculate the potential difference between point A and B. Then we need to find potential difference V. Means we can write here as VB minus VA equal to question mark. This is the potential difference. Then why put VB minus VA? Why don't put VA minus VB? We will look. I'll explain you after when we finish to solve some part. Then I'll show you why VB minus VA. Why not VA minus VB? Okay, we know. Okay, let's check first the potential from infinity to point A. What's the formula? Potential work by charge. Okay, let's say electric potential at point A is VA. Electric potential at point A is VA. Then this is formula is WA by Q. Then what is WA? The WA here is 25. Then Q here is 5. Then we got 5 into 5 will be 25, and we got here 5 volt. Now the potential at point A is 5 volt. Then next we need to find the potential at point B. Let me take that as VB. Then WB by Q. Because the same charge they carry, then the charge will be the same, 5 coulomb. Then work here is how much? 30. Then charge here is again 5. And 5 into 6, and we got 6 volt. Then potential difference, then thus potential difference is equal to, I'll write here VB minus VA. Why I put VB minus VA here? Because VB is greater than VA. If VA is greater than VB, then write VA minus VB. But here, since VB is greater than VA, then put VB minus VA. Because this B is close to the source charge, then B will have higher potential than A because A is far from Q. Then VB here will be 6 volt and A here is 5 volt. Then 6 minus 1 we get 1 volt. Now this will be the answer for this question. May the potential difference between point A and point B is 1 volt. And please solve this question number 2 and question number 2 from both practice problem 1 and practice problem 2. Then now we'll do the exercise. Okay, now we finished that practice problem. Now we'll come to exercise. This is exercise 3A. This is exercise 3A. Okay, question number MCQ, multiple choice question. Multiple choice question, I do only the last question, that question number 5. Because the order of choice are you already know it. Do check that last video and do solve that MCQ. Question number 1, 2, 3, and 4. Because this number 5 I'll do for you. This one, MCQ, multiple choice question. Then after that we'll solve this question that is on the same page, page 110, question number 3, 5. Then after this, we will do the last question for today. Then for this class, then we'll come to next. We'll meet back in next video. Okay, now let's start with this question. And which formula we have used, we'll check from here. I already write all the formulas of this first exercise. Okay, now current of 1 ampere. A current of 1 ampere. What I give? Current. The current we give 1 ampere. Is drawn by a filament. I mean that current is flowed where? In a filament of electric bulb. What is that filament of electric bulb? This is a bulb. Now here, that ever since there's a coil like this, now that will be called as a filament and it is made out of tungsten. We will come to that later, but at least this will be the filament. This is called filament. Filament of an electric bulb. Now in this filament, how much is the current? The current is 1 ampere. Then number of electron passing through a cross section. Now in this filament, because this filament is made of a wire, then let me make it straight. Now this is a wire. Then this also they have a cross section. Okay, let me make it big. Now this is the filament. Now this part will be the cross section. Okay, because every wire is looking in the shape of a cylinder like this. Now this we have this cross section. Now this will be called as the cross section. Okay. Now number of electrons passing through cross section means how many electrons are passing here in this cross section. How many electrons are passing through a cross section of a filament of this filament in 16 seconds. For 16 seconds, how many electrons are passing? Will be roughly, okay, now they give option A 10 to the power 20, option B 10 to the power 16, and option C 10 to the power 18, and option D 10 to the power 23. Now which is the answer? Okay, the answer will be, we'll have to solve it and check which one is the answer, either A, B, C or D. Okay, let's solve it and get the answer. Okay, now what they give here? Current. Okay, given, they give current symbol is I, that I already talked in last video. Symbol for current is will be current I is for how much I give here? 1 ampere. Then I write here 1 ampere. Then what else I give? Number of electron passing, we have to find number of electron in N. Number of electrons passing through this filament. In how many seconds? In 16 seconds. Okay, they give time is equal to 16 seconds. Now, we'll start to solve this question. Okay, now which formula we have to use? I is given, and T is given, and N we have to find. And here I is given, then T is given, but N we have to find, but here there is no N. But here, N is there, but there is no Q. Okay, but let's see. We'll have to make use of these two formulas. In this problem, we have to combine these two formulas. Okay, we know I is equal to Q by T. This is a relation between current, the charge flows in a conductor in time T. Okay, now if I take this T this side, cross multiply. Okay, take this T this side. Okay, then I'll do like this. I into T equal Q. I into T equal Q, or I can exchange this. Q is equal to I into T. But what is the value of Q from this formula? Q is equal to NE. Then in this Q, I can replace with NE. This is equal to I into T. I can write here since Q is equal to NE. This formula we get from the properties of electric charge. That quantization. Okay, then from here, we need to find N. Then I can take this E that side. Then N, then this in between N and E is a multiply. Then if we take to the right side, we change to division. Then I into T by E. I into T by E. And remember, I is already given, then T also is already given. But what's the value of E? The value of E, this I told you from reading, they won't give in the exam, you have to remember it. The value, because I already given you from the first video of this chapter. But what's the value of I? I is equal to 1. then T is equal to 16. Then what's the value of E? The value of E should be 1.6 into 10 to the power minus 19. Now we'll solve this problem, then we'll get the answer. Okay, I'll stop it here. Maybe this is still more space. Then now remove this point, then I can write like this. 16 by 16. Because 1 into 16 will be 16. Then if I remove this point, then 110 will go up. Now this 10 to the power minus 19, I'll take this upward by using exponential. Then that will change to 10 to the power 19. This minus will change to plus. Now 16 and 16 cancel. Then here how many 10? 1. And here how many 10? 19. Then we got 19 plus 1, 10 to the power 20. Number of electrons. Number of electrons. Now in 16 seconds, how many electrons are passing through this wire, through this filament of that electric bulb? It is 10 to the power 20 electrons. Then what is the correct answer? That is option number A. That will be the correct answer. Okay, now we'll come to the next question. Okay, now we will come to the next question on the same page, page number 10, question number 35. That is an electric bulb. Electric bulb, again, in last problem also we do about bulb problem. Draws a current of 0.2 ampere. When the voltage is 220 volt, calculate the amount of electric charge. We need to find the electric charge that is Q. Okay, now we look in this question. What is given? Electric current. Electric bulb draws a current. Which flows on that bulb? Current. And current symbol will be I. Current symbol will be I, that will be 0.2 ampere. Current, this will be the current flows on the electric bulb. And then when a voltage is 200 volt, voltage means that electric potential. Voltage means electric potential. And that will be V is how much? 220 volts. And then calculate the amount of electric charge. Then we need to find Q. Electric charge. This will be electric charge. Okay, now electric potential is given. Now which formula we have to use here? This is a direct formula. Which formula we have to use? I, V, and Q. An electric bulb draws a current of 0.2 ampere when the voltage is 220 volt. Calculate the amount of electric charge flowing through it in 1 hour. They give also time. Here how much? 1 hour. Time T is equal to 1 hour. How much the times of electric current flows on that bulb? For 1 hour. Okay, remember this hour is not the SI unit. Then we need to convert this hour to SI unit. Time SI unit of time is second. Then we have to convert to second. Then how many seconds in 1 hour? How many seconds in 1 hour? 1 minute. 60 minutes is equal to 1 hour. Then 60 seconds is equal to 1 minute. And 60 into 60 will become as, okay, I'll write it here. 1 hour equal to 60 minutes. Then 1 minute is equal to 60 seconds. Then 60 into 60, then we got 3,600 seconds. Then what's the time? 3,600 seconds. Now we got the time. Then what we need to find is, and remember this given here voltage 220. Don't confuse it. Simply they just given here, but in this problem we don't need this value. We need only this one and this one and this one. Only these three. Okay, then we know what's the formula. We know I is equal to Q by T. Then we can write this. Q is equal to I into T. Take this T beside, multiply. Then what's the value of I? I is 0.2 and T is 3,600. Now after multiplying here, okay, do the multiplication, remove this point, then 2 by 10. Because one number after point then will become 10. If two number will become 100. Then 3600, then this 0 and this 0 cancel. Then 2 into 36 will be 72. 2 into 36 be 72 and this 0 will be. Then how much is the charge? 720 coulomb. Now this will be the answer for this question. Now we'll come to next question. Okay, then now we'll come to on this question on page 111, question number 522. Then they give a state relationship between. Then I just write here the question. You check for the question from the textbook. We can give a state relationship between the electric current, then the charge and the time of flow. We need to check the relation between current, then the charge and the time of flow. Then what's the relation between this? The relation between this this one. I is equal to Q by T. Then you can write that answer in relationship. That will be I is equal to Q by T. Then please don't forget to write what does this I stand for. Where I is the electric current. Then Q is the charge flowing in a conductor. Then time, and then T is the time of flow. Okay. Then now by using this formula, we'll solve this problem. Calculate the charge passing through an electric bulb. We need to find again Q, like last question. Calculate the charge passing through an electric bulb in 20 minutes. If the value of current is 20, this MA here, small m, capital A, 20 milliampere. This M here stands for milliampere. Then remember, this milli is always 10 to the power minus 3. Remember, this milli is always 10 to the power minus 3. Okay, now use this formula to find this one. Okay, otherwise what is given? Charge passing through, we need to find. Okay, now Q is equal to question mark according to this question, because we need to find charge. And then passing through an electric bulb in 20 minutes, then give time 20 minutes here. Electric bulb in 20 minutes. Then if the value of current is 20 milliampere, value of current I is 20 milliampere. Then I told you that milli is 10 to the power minus 3. Then I write here 20 into this in place of this milli. I write this one 10 to the power minus 3 ampere. Now this is the SI unit of current. Otherwise, milliampere is not the SI unit. This will be the smaller value. Then 20 to 10 power minus 3 ampere. Now we got all the given data. Then we can solve it. Then we know I is equal to Q by T. Again, this will be the formula. This one I is equal to Q by T. Then we need to find Q. Then Q is equal to I into T. The same like this last question only. Then what's the value of I? The value of I is 20. 20 into 10 to the power minus 3. That's the value of I. And then T. What's the value of T? T is 20 minutes. Again, this also is not SI unit. Then we have to change it to SI unit. Mean minute you have to convert to second. Then 1 minute is equal to how many seconds? 60 seconds. Then I write here 60 seconds. Then this becomes 2 into 6 will be 12. Then 120 seconds. Then in place of this T, I write 120. Okay, now we'll do multiply. Then 2 into 12. 2 into 12 will be 24. Then here will be 0. Then here also will be 0. Then like this 10. Here 1 0 and here also 1 0. Then 10 to the power 2. And here will be 10 to the power minus 3. Then here we got, you know the formula, law of exponential, that a to the power n into a to the power minus m. And this will be called to a minus m. This will be the formula. Then here we use that formula. Then here we have 24 into. Now 2 minus 3 we got minus 1 according to this formula. Then we got here minus 1. Then this minus 1 it means like this. 24 divided by 10. That minus will take down, we change to positive one. Then 1 we don't need to write. Then 24 divided by 10 becomes 2.4. Then what is they ask? Charge Q. What's the assignment of charge? Coulomb. Remember, don't forget to write the SI unit. Now this will be the complete. And some question I'll ask you to do. Okay, now this question is from your textbook, page 111, page 110. You can do myself and send it to my WhatsApp number. And please do send it. Okay, and this question number 3.1, then 3.2. Question number 5, 3.1, 3.2. Now question number 3.1, it is asking that how is the direction of electric current? How is the direction of electric current is related with the direction of flow of electron in a wire. Remember this once I forget to explain you. Remember, I'll write the answer for this. Or they be asked in this way the question. Who constitutes the flow of electric current? They may ask that question. That is same as this question. How is the direction of electric current related to the direction of flow of electron in a wire? That's the question in your textbook. Or they may ask you, who constitutes the flow of electric current? The flow of charge constitutes the flow of electric current. But here the relation is, the direction of flow of electric current is always opposite to the direction of flow of charge. Direction of flow of electric current is always opposite to the flow of electrons. Remember this, if you ask you who constitutes the flow of electric current, it is electron. Who's responsible for the flow of electric current? It is electron. Then from where direction electric current flows, it flows always from higher potential to lower potential, that is for conventional current, not for electronics current. And remember, it is always opposite. If this is a conductor, now if the electrons are flowing this direction, example, this is electron are flowing this direction, and remember the electric current will flow this direction, conventional current, that is opposite to the flow of electron. Now this will be the electron and this will be the current. And this question number 3.2, that will be you do by your own. Then this question number 5.1.1 and 5.1.2 also do by your own. Then page 110, question number 4.5, this also you try and solve it. And page 110, same question number 2.1.1 to 8 and question number 3.1 to 3. This all you have to submit it. And thank you. We will meet back in the next.